Okay, we start session number 4.
Yep.
We'll discuss testing of IP PBX or cloud PBX. Testing for IP PBX cloud providers. When provider doesn't know what is called capacity of PBX, does it handle 50 concurrent calls and 10 calls per second, or 100 calls, current calls? It also depends on hardware. So they install IP PBX on some virtual server, and we need to make sure that it will work in peak hour. Okay, and I have IP PBX 3CX installed already. I'll open the 3CX. It's here on my server.
Okay.
So there are extensions, just test extensions of 3CX, 25 extensions, and they are offline right now. And I will register SIP Tester as multiple extensions. So SIP Tester registers at PBX as many phones, many IP phones, and the provider can test manually using Zoiper, X-Lite, IP phone, but it is hard for them to test 25
all of them
at a time. It has to be done automatically in SIP Tester. So okay, we start with SIP Tester. And we will add UAC registrations. UAC means user agent client. I wrote about it in a book. I will continue this book. Book is user agent client. It is a concept from SIP standard. So it is a standard concept. Client and server. PBX is server, and SIP Tester is client in this case. In this test, we add new extension. It is what 3CX. The 001 username 001 authentication username. Let me check what's the password. Password. I have to find it. I found the password. And it sends to domain. 3CX, they have automatic domain names. This is DNS name, but usually it is just regular IP address. And SIP port is 6080. Register is sent. What do we see? We can see SIP trace. Oh,
register.
okay. Now it's here.
Oh.
It replied. So, what is registration? Registration means that SIP phone tells to PBX, I'm here, and I have this number, and this user 001, and then PBX replies with 407, authentication required. Tell me username and password, and the server sends a proxy authenticate SIP header, which contains digest. Well, people who are interested should read about SIP digest authentication. So PBX requests authentication, and in next register the authentication password is sent in the same header, proxy authentication. Digest and digest response. It is not plain text password, and a person who captures this traffic, he is not able to see the password. He is only able to see the extension number, but he can enumerate extensions later if he is a hacker. Okay, register, and finally PBX responds with OK. Register succeeded, and itself expires in seconds. It is time for re-registering, maximum timeout when the register will be expired. So in 1,800 seconds, SIP Tester will send register again.
Okay. So if you try,
and we can also re-register manually and see trace. So we send register again. This is new register, and this time it responded faster. This is small delay. Okay, we register, added one extension. We check server. Check the server PBX. Extension is online.
Yeah, registered. Yeah.
These two extensions are from my another SIP tester running at this time. So, and on this SIP tester instance, we register 001, 002. Well, let's do 4 extensions as an example.
Okay.
Okay, we register. Add new registration 002. It responded with user unknown because it was user number 2. It was not correct. I mean, 002. Password is the same, but username is different. Authentication username. Authentication username can be different from extension number. But they are usually same. It's like web login and web password. This is like nickname. Okay, 0003.
Okay, should be true.
Yes. And one more. 004. 04. Okay. User can save extensions to CSV file. You will see registrations. Save to CSV just to export data from this table. Save to CSV and load from CSV. Delete all extensions and add. Now we added manually, but user can add extensions in a batch. When we need to add 1,000 extensions, SIP Tester can simulate thousands of extensions. Okay, it is about batch. TCP, there is a transport. It is UDP now, but register and SIP invite can go over TCP and TLS transport layers. UDP can be captured by Wireshark, by man-in-the-middle. If you know man-in-the-middle attacks, when a hacker or network provider, someone in a network provider captures your traffic, and he sees exactly same SIP trace over UDP and over TCP, it is insecure. Over TLS, it is secure, and it becomes popular to use TCP. To use TLS. TLS, it is like HTTPS for browsers, and TLS for SIP. SIP protocol. But it is slower than UDP. UDP protocol was selected because it is very fast. It does not have to establish connections. Okay, register, we can unregister here. Delete unregisters and see SIP trace. Unregister means registering with expires equals 0. It means that registration will expire in 0 seconds. You understand? I cannot hear you.
Okay, so I mean, like when we click unregister, then it's unregisters right away, right?
Yeah, right away. It sends new register packet to server with expires equals 0. And it means that the registration will expire on server with in 0 seconds.
Yeah.
Okay, register again. What else? Call ID. Call ID is a header. It's like unique identifier or in register request. We can disable extensions temporarily without deleting, not to use them in test, and use only for these things are documented. Single channel. Most PBXs allow only one call per extension, one concurrent call per extension, not two. You can edit format of contact header and expires interval. You can set to 90 seconds, for example, and it will re-register faster. And faster re-registration is better because PBX can restart, server can restart, and the new restarted server will not contain information about old registration if you don't have a database. So to avoid downtime, it's better to have low interval, but it sends more packets and it generates more load on server. It can be tested. It's about register, and register can also be sent in scripts in CallXML. I mean, before calling, you can put register. CallXML documentation. The register. For example, if you read passwords and users from CSV file, or you generate them based on some logic in XML, you can send a register. Or if you are a hacker, you can read the usernames, the passwords from a file, and you can send registers.
Oh, okay, yeah.
Not a hacker, but well, white hat hacker.
yeah. If you know the information, then you can use it.
Yeah. So you can register like in XML.
Yeah. Okay.
And also in the user interface here, okay, we see register is completed, outgoing, and what do we see all registrations online in 3CX? Yeah, online. Registrations online. Now we want to generate calls between extensions in user interface. There is a mode generate calls via least busy UAC registration. It means select registration which doesn't have concurrent calls right now, and make call between them, and terminate call, don't need to terminate, and after 20 seconds. In XML it looks like this, just simple syntax. Okay, we create a call and we see outgoing generated and incoming received. And this is a simple test. We create one more call. It selected another pair of extensions, and one more call is it is complete. One more call. More calls are not possible because all are busy, and it writes to log. Do not create a call. No channels available, or set single channel equals false, because currently the registrations are configured
a single call,
single channel, one channel at a time. If we remove single channel to allow it
multiple
calls, what do we see? Ongoing create more. The PBX, does it allow by itself? It allows more calls. It allows. So this 3CX PBX actually allows such
multiple calls, right?
Multiple calls per extension, and we can search for limits. Let's put 28. License is 25. Free license for 3CX now is 25.
Okay.
And looks like all calls, no rejected calls.
All calls are connecting.
And what do we look for during this test? We look for RTP 56, some lost packets. So maybe this is not a good internet connection. Maybe there was some packet loss. To remove this element of internet, we can run a test from IP to IP in the same data center to test only the server. and we see some delays. I don't know how it allows 28 channels while free licenses. Oh, I see that it doesn't receive calls. You see, R.
Oh, okay. Yeah, yeah.
Receives calls, and we can we can record the calls in settings. Settings.
Well, we can
record calls, and
okay.
And we can hear. Most probably, it tells to user that it's not extension is not available. I don't know.
Yeah.
So
Like a busy sign? Yeah. Yeah, this is all busy. Oh, no.
Maybe. Okay, I stop. I'll go in calls. Stop and check the recording. Recording. Oh, there. Show recording. Listen. Listen.
Calls has been reached. Contact administrator.
What?
Calls has been reached. Calls has been reached. Contact administrator.
Some IVR.
IVR? Oh, okay.
What?
I don't hear that.
I don't understand.
Calls has been reached. Contact administrator.
So it is not actual call between extensions, and it is an error message, I think. Okay.
But it says 200 okay. Why is that?
200 okay means that it has been answered with IVR.
Oh, okay. Answered. Okay.
IVR is also okay.
Mhm.
Create single call. When we create only one channel, it generates incoming call.
Okay.
One more call. Okay. Also. No. Yeah. Outgoing and incoming. And one more call. What? No incoming call.
Yeah, just out. Yeah.
Just out and no incoming. And
So also 3.6 doesn't allow multiple calls, I think.
Yeah. I think it is configured, and it is not natural that one extension will make multiple calls.
Yeah.
It's not a outbound call center with many agents.
Yeah. So PBX usually have like one call at a time.
Yes. Okay. What else we can do? We can check audio. We can do audio verification. So the audio is not. How to check that the call is really connected between extensions? Well, we can check by the statistics, number of received calls.
Received calls 7.
7 received and much more attempted. We can reset counters, set to limit number of calls outgoing equals 2.
Okay.
Set some interval, and we can run a test. And over time, we can monitor what is the number of received calls. Is it equal to a number of attempted calls? If it is less, then we know that some call didn't go through PBX.
Okay.
And that's a test. And let's see, is correct or not?
Yeah. I think you selected 2, so it's gonna be okay for now.
But I don't believe, because I didn't test it, I don't believe that. Now it is okay, but maybe sometime there must be some interval between calls. Maybe PBX will not allow. Okay. It can be tested. Okay. Next thing. Register, set up register, make calls between extensions. We did this. We can check audio. Check real audio path between extensions. And the test will go like this. SIP Tester as extension PBX. Also SIP Tester as extension. And place echo audio. And play speech.wav file and verify echo at this point. And if it doesn't go to our extension, it will not receive echo. It will be different sound. And so we will set up it in CallXML. CallXML verify audio, and I'll start explanation of audio verification. Okay, stop. First, in incoming calls handling, we edit XML. Edit. It accepts calls. We don't need this. We accept calls immediately. Make script very simple. Accept call and loop back audio. Loop back audio. This loop back audio. And we can put some max time. Let's see, maximum 1 minute. 1 minute. This is very good feature of SIP Tester, and it's a major selling point of SIP Tester. There are many dialers, but not. They don't verify actual audio. They don't decode RTP. They don't compare sound file. Loopback audio max time equals 60 seconds. 60. So okay, we just play audio. In outgoing script, what do? We verify audio. First we play audio, but not music. Let it be music. But we also need to verify audio. It is not valid XML. It doesn't have any parameters. And let's search verify audio. Show details and has parameters. A reference is required. A reference is a file. It is a correct file. Reference file. A file which is expected to be received from destination. Verify reference equals same music.wav file. And in play audio, we need to put a parameter. Don't wait equals. I'll check it. By default, it waits for these 20 seconds and it doesn't go to next element. So do you understand? We just start playing and we don't wait for completion. We don't wait 20 seconds.
Yeah.
And we go to next element. verify audio immediately.
Okay. Yeah.
Verify audio. What's next? And we will use a real-time algorithm. There are many modes of audio verification. There is fast mode. It is slow and it takes CPU. And now we use G711 codec, which and with G711 it is possible to verify audio by exact bit comparison. Wait. Okay, this real-time mode. Here is explanation, and we use this parameter weight constant threshold. It's here an example. We put our music well. What's the time max time that we listen? And well, the music file is 60 seconds long, and I don't want to wait for all 60 seconds, and there is a much shorter WAV file in the follow installation, speech.wav. It is 14 seconds. Speech. I just want to save time. Don't wait for long. Okay, this is copied from example. Verify audio, we only change reference file. It waits for 14 seconds maximum, and it waits for 100 confidence. What confidence means? Confidence is percent of correctly identified audio frame. It says and it waits for 100% match. Or it waits for 14 seconds. One or another. And it saves result confidence into variable XML and delay between starting of verification and actually receiving audio back. There could be a big round-trip delay over satellite, for example, satellite internet, or some other bad internet with big delay. Big delay is not good. Also, when quality is good, a big delay can make us not possible to talk.
Yes.
Delay is also important, and it says the indicators to CDR. Okay, create call. Let's see what happens. We can also write it to log, to XML log. Just to see it immediately on screen. Write it Okay, and we're observed in log. Okay, see. Ah, 0. Maybe because setting is not correctly set. What's the codec?
G.
It is
G7.
79 for incoming call. It is incoming G7 to G7 to 9 codec makes impossible to check audio by comparison, exact bit comparison, and when we accept a call, we can put the codec specifically here. Codec equals G7A, and when we generate a call, we also set the codec. This is like a framework for test. It's like an environment for test, and it's a language for testing, and it is very flexible. Make it wonderful again.
Okay.
Okay. Let's see. Waiting. Oh, 20. Slow.
Yeah.
File. And don't know what. To debug, why this slow? I don't know. Need to listen to recording. And also that settings. Enable partial frame offset in real-time audio verifier. There could be partial frame delay. I don't know, and I better set it to 1 because I don't know.
Okay.
Oh, more confidence? What? Settings. Set it to 1. And record. Let's see the recording in debug media folder. The default path for recording is C/debug media and save. It's a new recording. And we open the recording to see what's the reason. I'm not sure. It recorded both outgoing and incoming call, and I don't.
Both showing both be the same.
I don't see clearly the audio. To avoid confusion, what is incoming call and what is outgoing call, I remove recording from global settings, and I turn on recording for the audio verification. It is a parameter of verify audio debug recording threshold. space to debug recording over audio if confidence is less than the threshold. And I set it to 99, so equals 99. So all calls with confidence less than 99 will be recorded. I create it again, and this is a way to debug audio verification to understand what happens, why it is not perfect. In debugger recording, debug media. No new files. Oh, it was 100. It started to work, you see?
Wow.
But there was something wrong. And I have recordings now. What was wrong? Let's see. Probably the first call is incoming first by time, because first is outgoing and another one is incoming, and I see this is outgoing call. I'll check it.
Hello. Hello. Hello.
This is okay?
Not this is.
Hello. This is Star. Hello.
Yeah, but I can hear it.
Break.
Yeah, I do. Yeah.
But not like.
StarTrinity Tester.
Right?
The voice audio sig.
Not. It doesn't sound like 20%. 20% is only 20% of audio is correct.
Hello. This is StarTrinity Test.
I'll check again.
Hello. This is StarTrinity Test call. The voice audio signal is used to verify quality of SIP and PSTN networks and VoIP gateways. The StarTrinity software compares received audio signal with reference file and produces MUX score.
Maybe it was not a good call. Maybe this call was not for 20. We can check by call ID. What? There is a call ID. The call ID in CDR. There is a call ID, and I can track by call ID. And
I'm gonna check.
One more file.
Okay.
Hello, this is Star.
It's also good.
Hello, this is StarTrinity Test call.
Don't know. Okay. Let's just make more calls and see what happens. Yeah. Okay. So I restarted SIP Tester and CDR field appeared in reports. And
is the delay okay? 110 is it too much?
Delay? You mean? It is milliseconds. It's good.
Oh, the
milliseconds. So not
milliseconds. Okay. Yeah.
You cannot hear such a delay. You can hear maybe 300, 400 milliseconds. You can hear. This is very slow, and this is full path delay between PBX. And does the audio go through PBX? Because now it can go in SIP. in SIP, audio can go directly from SIP Tester from extension to extension. But I configured PBX to pass through PBX, pass the audio, and we can see it from SIP trace. What is the SIP trace is not good. It doesn't respond to OK. It's not good. Well, I was testing audio, but I found something wrong with SIP, and it is absolutely not normal that PBX doesn't respond to 200 OK. That must be a hack. I was going to check what is IP address of the server. It is available in our RTP stream fields. RTP stream. Okay, you see here RTP goes through IP address of PBX. It doesn't go between local and local IP address. So it really goes through PBX.
Yeah.
Okay, and we see confidence is good, and we can see summary for the confidence in the report. Global minimum is 99.46. This confidence. It's a very good confidence. So result is great. And what we do? We set to 3 concurrent calls, and as we know from previous tests, there will be IVR, not not correct audio, but IVR. And let's check CDR. What happens for you see confidence 0.
Yep.
Confidence is 0, and we go to recording and check recording in debug media. Here are 3 recordings with confidence 0. So we're on the test. We got some calls with 0 confidence, and we open in audio editor, and we see,
Record your message and press pound, or press star to contact the operator.
You see, it's voicemail message. It is not.
It
is not echo, and it is voice voice message. Okay, this is pretty much for IP PBX testing. We test full audio path. We test registrations, calls between extensions. So that do you understand?
Yeah, definitely.
Okay, so
it's pretty straightforward. Yeah,
very straightforward.
Yeah.
Okay, for some calls confidence is good, for some it's 0, and this is audio verification. And this algorithm, bit match, real-time audio verification, it compares G711 audio frames to reference files, and it is able to handle about 1,000 concurrent calls per channel per server. It's very powerful. So 1,000 extensions. It's a big number. And hardware requirements are very different. For SIP Tester, it can run on virtual server based on tests, depending on complexity of CallXML server. Server requirements are different. Okay, I stopped this session recording then. Okay.